When we think of worlds with rivers, lakes, and rain, we naturally think of Earth. But there's another place in our solar system where liquid flows across the landscape, carving valleys, filling basins, and evaporating into clouds. That place is Titan, Saturn's largest moon. Only here's the twist: the liquid isn't water. It's methane, and the temperature is so cold that water ice is as hard as rock. Titan is one of the most Earth-like worlds we've ever discovered, not because of its temperature or composition, but because of its geology. It has dunes, mountains, lakes, and even weather. It has a thick atmosphere, something no other moon in the solar system can claim. And beneath its icy crust, there may be a liquid water ocean that could harbor life. Today, we're going to explore this strange, familiar, yet utterly alien world. A moon that feels like a snapshot of early Earth, frozen in time. A hidden world. Titan was discovered in 1655 by the Dutch astronomer Christian Huygens. For centuries, it remained a mysterious dot of light. Then, in 1944, astronomer Gerard Kuiper made a crucial discovery. Titan had an atmosphere. It was the first moon known to have one. Later, when the Voyager spacecraft flew by in 1980 and 1981, they revealed that this atmosphere was dense, even thicker than Earth's, and composed mostly of nitrogen, with a significant amount of methane. The surface, however, remained hidden. Titan's atmosphere is opaque in visible light, shrouded in a thick orange haze of organic molecules. It wasn't until the Cassini mission arrived in 2004, carrying the Huygens probe, that we finally saw what lay beneath. The probe descended through the clouds, revealing a world that looked eerily familiar. River channels, rounded pebbles, and a landscape shaped by liquid. A hydrology like no other. On Earth, water evaporates, forms clouds, and falls as rain. On Titan, the same process happens, but with methane. Methane is a gas at Earth's temperatures, but on Titan, where the surface temperature hovers around -179 degrees Celsius, -290 degrees Fahrenheit, methane behaves like water does on Earth. It can exist as a gas, a liquid, and a solid. The result is a complete methane cycle. Methane evaporates from the polar lakes, forms clouds in the thick atmosphere, and rains down onto the surface. The rain carves river channels, erodes the ice bedrock, and fills the lakes. This cycle is sustained by a complex interplay of sunlight and atmospheric chemistry. But there's a puzzle. Sunlight breaks down methane in the atmosphere, so it should have been depleted long ago. That means there must be a source of methane, perhaps from cryovolcanoes or from a subsurface reservoir, replenishing the atmosphere. Carved by liquid methane. When the Huygens probe landed in 2005, it sent back images of a landscape that looked like a dried-up riverbed. There were rounded pebbles, smoothed by flowing liquid. Later, Cassini's radar mapped vast networks of river channels across Titan's surface. Some are narrow and meandering, like Earth's rivers. Others are wide and braided. They stretch for hundreds of kilometers, draining into lake basins. What's striking is how similar these features are to terrestrial rivers. Yet, they're carved by methane, not water. And the bedrock is water ice, which on Titan is as hard as granite. The rain that feeds these rivers is methane, falling in occasional storms that can drench the equatorial regions. This is a world where the landscape is actively being shaped by a liquid that would evaporate instantly on Earth. A northern oasis. Titan's polar regions are home to hundreds of lakes and a few massive seas. The largest, Kraken Mare, is about the size of the Caspian Sea. Ligeia Mare is a methane sea filled with liquid hydrocarbons. These lakes are concentrated in the northern hemisphere, while the southern hemisphere has fewer and smaller lakes. Scientists think this asymmetry might be due to seasonal cycles or to long-term orbital changes. The lakes are not filled with pure methane. They also contain ethane and other organic compounds. And they are remarkably flat. Radar measurements from Cassini showed that Ligeia Mare has a surface variation of less than a few millimeters, smoother than any natural body of water on Earth. This flatness suggests that the lakes are deep and possibly connected by underground channels. A desert landscape. While the poles are wet with liquid methane, the equatorial regions of Titan are dry, a vast desert of organic sand dunes. The dunes, known as the Shangri-La Sand Sea, stretch for thousands of kilometers. They are made of tiny particles of solid organic material, formed when methane in the upper atmosphere is broken apart by sunlight and falls as a fine, dark powder. These particles then accumulate into dunes that look remarkably like the sand dunes of the Namib Desert on Earth. The dunes are shaped by wind. Titan's atmosphere, though thick, is relatively calm near the surface, but winds are strong enough to move these organic grains. The orientation of the dunes indicates that they are shaped by prevailing winds from the west, consistent with atmospheric circulation models. So Titan is a world of contrasts: a wet, lake-dotted north, a dry, dune-covered equator, and a complex global climate. A hidden ocean. Beneath Titan's icy crust, there's another secret. Measurements of Titan's rotation and gravity from Cassini revealed that the moon is not a solid, rigid body. The crust appears to be decoupled from the interior, meaning there is a liquid layer, a subsurface ocean of water, likely mixed with ammonia, which acts as antifreeze. This ocean sits between the icy crust and the rocky core. The existence of this subsurface ocean makes Titan one of the prime targets in the search for life. On Earth, wherever we find liquid water, we find life. Titan's subsurface ocean might be a habitable environment with water, heat from tidal forces, and potentially chemical energy from the interaction of water with rock. If life exists there, it would be completely independent of the exotic surface chemistry, a second biosphere hidden beneath the ice. The next mission. NASA is sending a mission to Titan to explore this alien world up close. Dragonfly is a nuclear-powered rotorcraft, a drone scheduled to launch in the late 2020s and arrive in the 2030s. Unlike previous landers, Dragonfly will fly from site to site, covering dozens of kilometers over its mission. It will land on the dunes, sample organic materials, and explore the Selk impact crater, where liquid water once existed and where prebiotic chemistry may have been active. Dragonfly's goal is to understand Titan's organic chemistry, to look for evidence of water-based or hydrocarbon-based life, and to uncover the processes that make this moon so Earth-like. It will be the first mission to fly a powered aircraft on another world, and it promises to revolutionize our understanding of Titan. A mirror to Earth's past. Titan is a world of paradoxes. It's bitterly cold, yet its surface is shaped by rain and rivers. It has a thick atmosphere like Earth's, but its skies are orange, and its rain is methane. It has lakes and seas, but they're filled with liquid hydrocarbons. And beneath it all, a hidden ocean of water may harbor life. In many ways, Titan is like a frozen snapshot of what early Earth might have looked like before life emerged, a world rich in organic molecules with complex geology and a dynamic climate. By studying Titan, we're not just exploring a moon. We're looking at the chemical processes that may have led to life on our own planet. And with Dragonfly, we'll finally have a chance to explore this alien world in unprecedented detail. What excites you most about Titan? The methane lakes, the possibility of life in its hidden ocean, or the chance to fly a drone on another world? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.